Comet ISON. And what do we have here? An ice-on-Earth impactor. Oh no! Well, don't worry, it's just a virtual Earth impactor. It's not an actually detected object, it's just a hypothetical object, because we're going to answer the question of what it would take to send fragments of ice onto Earth. We know from looking at the stereo and the SOHO images of perihelion that it didn't hold together. And so the question is, if the cloud of dust that we saw leaving the sun contains significant fragments of ISON, do those fragments have any risk of hitting Earth? So to answer that question, we first need to find out what it would take to send fragments of ISON to Earth. And the answer turns out to be about 57,000 meters per second delta V, which translates to about 57 kilometers per second delta V. That's a lot. But this virtual spaceship that I put at the orbit of ISON has received that delta V. The residuals are all less than 1 meter per second in each direction, and basically that means that this virtual spaceship is now headed towards Earth from the orbit of Comet ISON at perihelion. And this can serve as a proxy, a virtual impactor that represents a hypothetical fragment from ISON that reaches Earth. So we can load these orbital elements into Starry Night and see where it would be in the stereo ahead images if it were indeed possible for that dust cloud containing potential fragments of ISON to reach Earth. So we can see, if we fast forward through time here, these two positions, the position predicted for ISON and the position predicted for the Earth impactor, diverge over time, and in mid-January, when ISON would be passing above Earth's orbit, the virtual impactor hits Earth. But the question is that possible? Is the debris cloud that ISON left behind big enough to envelop Earth in mid-January? So we have here the view from stereo ahead, and we're going to zoom in here and take a look at what we see. So on December 4th at 5:29:01 Universal Time, the virtual Earth impactor is right next to this star right here, and ISON is up at the top of the frame here. Now this is approximately the view from stereo ahead's heliospheric imager number 1, and I have that image astrometrically solved right here. Now I've taken the coordinates from Starry Night for the virtual Earth impactor at that point in time, which is the same point in time as the image, and I've used that information to show you where in the image the dust cloud would have had to expand to in order for any fragments in the debris to reach Earth. And you can see that point right here. And there's that star we saw in Starry Night. This star right here, visible in the actual image right here. And let me just show you the region. So there's the region and the coordinates of where it would have to be. And ISON, on the other hand, is up here. Now this is the predicted position for ISON for the original comet, and as you can see, the debris cloud is continuing to follow that orbit, and it's nowhere near the position it would have to be if any of the fragments were going to hit Earth. So no, it's not a risk to hit Earth. Even if there are significant fragments in the debris cloud, there's no chance that they could hit Earth. And so far, searches for any significant fragments of the comet from the ground have turned up empty. There have been searches down to magnitude 16, maybe even magnitude 18 at this point, and so far nothing has turned up. So it doesn't really look promising for anything significant to be left of the nucleus. It appears that the comet is pretty much gone. If there's anything left at all, it's not outgassing at this point. And the debris cloud certainly is nowhere near where it would have to be for potential fragments from the comet to reach Earth. Now, you may have noticed I mentioned ISON passes over Earth's orbit in January. That's where the orbit takes it. Now that's not the point of closest approach, that's actually on December 26th. But at that time, it hasn't yet reached the, it's not yet reached Earth's orbit. It's not actually directly over us yet. That happens in about mid-January, and that's when the virtual impactor would end up hitting, if it did. But as it turns out, as we can see in the stereo images, that's not a risk and not a real concern. So with that, I hope you have a nice day. It's that time again, time for yet another video about Comet ISON. And what do we have here? An ice-on-Earth impactor. Oh no! Well, don't worry, it's just a virtual Earth impactor. It's not an actually detected object, it's just a hypothetical object, because we're going to answer the question of what it would take to send fragments of ISON to Earth. We know from looking at the stereo and the SOHO images of perihelion that it didn't hold together. And so the question is, if the cloud of dust that we saw leaving the sun contains significant fragments of ISON, do those fragments have any risk of hitting Earth? So to answer that question, we first need to find out what it would take to send fragments